I'm Phil Laudicina, Engineering Manager for Marmon Industrial Energy and Infrastructure, and I'm here to talk about TCERHL codes. TCERHL was added to the 2014 National Electrical Code after several years of individuals asking the code panel to include a flexible alternative to type MCHL. The cable is listed to UL 1277, which is the basic standard for power and control tray cable, as well as UL 2225, which is the standard for cables for hazardous locations. The cable is suitable for Class 1 Zone 1 locations per Article 505, but in that article, the limitation of 1 inch in diameter was put in. And the reason it was put in was because manufacturers were having difficulty with small metal-clad cables under 1 inch. So they decided to allow for flexible cables under 1 inch in diameter. That was their basic cutoff point. Also suitable for Class 1 Division 1, but with a caveat of flexible connections per NEC Article 501. Again, and the 1 inch limitation was based on the Zone 1 restriction. Flexible connections was kind of unclear because many manufacturers or users weren't clear what that actually meant. What's a flexible connection? What's not a flexible connection? So it kind of still gave them a little difficulty in using that cable in lieu of a metal-clad cable. And eventually they kept pushing, and you'll see later on that eventually that restriction went away. The cable has to have an equipment ground conductor size per Article 250.122, same as TCER. Now here's an illustration of what TCERHL, MCHL, and even ITCHL looks like. These are the 3 cables that are HL listed. As you can see here, the TCERHL is just basically conductors in a jacket, doesn't have to have any metal other than the conductor itself. MCHL has a corrugated aluminum armor, can be copper as in our vital products, and of course ITCHL, which is more instrumentation cable, also has the corrugated armor. Mechanical performance, type TCER and type MC must meet the same mechanical performance criteria. TCER was added to the code in 1999, and it had to be deemed equivalent mechanically to metal-clad cable in order to come off the tray and be used for runs to equipment after the tray. It is continuously supported and it has to be secured every 6 feet. Same is true with TCERHL. The only difference is HL is a Division 1 or Zone 1 area. So as you can see, crushing and impact requirements are the key. And the samples that have to be tested are a free conductor 14 gauge with ground and free conductor number 2 gauge with ground. And as you can see, crushing and impact for TCER and type MC are the same. But for the HL cables, and this is all of them, MCHL, ITCHL, and TCERHL. For the 14 gauge, the crushing resistance is higher, it's 1,500 pounds, and the impact resistance is higher, it's 25 foot-pounds. The 2 gauge, there was no change to the criteria. The other change is that in those cables, they must comply with a -25 C impact test. Now, many cables pass -40. The -40 is a nice to have. It's used in Arctic areas and areas where you have very cold temperatures, but it's not a requirement. So the basic minimum is -25 C. Flammability-wise, HL cables must pass IEEE 1202, which is the same test as the CSA FT4. The IEEE 1202 is a more severe flame test than UL 1685, which is the basic flame test for power and control tray cable. And the reason it's more severe is for 2 reasons. Angle of burner and the cables under a 1/2 inch in diameter are bundled in the tray. The standard UL 1685, which covers this test, tells you how you bundle the cables, how many cables are in a bundle and how many bundles go in the tray based on the cable diameter. Now here you see an illustration of the 2 flame tests. In both cases, it's 70,000 BTUs of heat. For 1685, the flame is applied 18 inches above the floor at a horizontal angle, basically parallel to the floor. In the 1202 test, it's applied 12 inches above the floor at an angle of 20 degrees. And this imparts far more heat to the specimen than in this test. In both cases, they are burned for 20 minutes. And then after the test is completed, the char height is evaluated. Char is the only damage criteria you use to evaluate whether or not the cable has complied with the flame test. And in 1685, the requirement is as long as it's under 8 feet of char damage, you pass. 1202, you have to be under 1.5 meters, which is roughly 4.9 feet. So a much more severe test with a much more stringent criteria. So HL cables are very flame retardant. In 2020, some major changes happened. The limitation of flexible connections was removed in that the cable was given equal footing, if you will, with MCHL. It was no longer in the section that specifically talked about flexible connections. However, Article 336 added two new requirements that were not there previously. There was some controversy with this because Article 336 is handled by Panel 6. They don't have any jurisdiction over hazardous location cables. That's Panel 14, which handles Article 501 and 505. It went up the chain of command in the NEC, but it was allowed to stay. And the new requirements are that if you are larger than 1 inch, you have to have a ground conductor and it must be uninsulated. Otherwise, you had a choice in the past. Here you do not. And the cable has to have an overall shield under the jacket. So this became significant in that the OD of 1 inch is really more of an arbitrary thing, which was done back, as I explained, because of the cable smaller than 1 inch, the metal clad breaking. And then they put this in as a restriction, but that does not really indicate any power demand or usage, which would necessitate a shield or a ground conductor being uninsulated. What we offer in our family of products is X8 oil rig, our Rock Flex, Rock Tough, and Vitalink products, and Decaron Wire and Cable also offers TCERHL. And we're continuing every day to do product development to expand this portfolio to bring you even more TCERHL products. Thank you for your time.